about logs and exponents. And to be honest, Blaine, you have to kind of memorize them. When other teachers teach this, they teach it from a book approach. This was in my oldest son, Michael, he's 28, when he was like, and I'm out. Because he's like, this doesn't even make any sense. So I'm going to explain it to you, and then I'm going to tell you there's a shortcut to memorize, right? But I'm going to explain to you why it works. There are 3 weird situations. There's no other way for me to explain it, but they pop up. So Michaela's watching me, and they're weird. So I need you to write this down. And I need you to write down that here's what's weird about him. He's going to have a base, he's going to have a number, and that number is going to have an exponent. It is very crazy looking. It's got a basement, a regular floor, and an upstairs, right? And if you look at that, like, again, Michael, my oldest, was like, and I'm done, this doesn't make any sense. So I'm going to show you the way to do this problem, and then I'm going to show you the shortcut once you recognize it. So here's what's weird about it. What I want you to realize is sometimes the base and this guy, the argument, are the same number. And when that happens, a cool thing happens. So watch what I'm going to do. I'm just going to rewrite this baby. I'm going to say 4 to the x equals all of that stuff. 4 to the 57. This problem, look at it, it should be super easy for you to do. If I've got 4 to the x equals 4 to the 57, what does x have to be? 57. Absolutely. Those just cancel out. So here's the shortcut. When you see a log with a base to itself, you get to, in essence, like it's cheating a little bit, cancel them out. They cancel each other out. So it would simply be, I don't want that, stop that. It would simply be 57 is x. Is that cool? So I want you to try one, and I don't want you to do any real work. I want you just to look at it and think, oh my God, is it that easy? So you're watching for these ones. If you forget about them, can you do it the long way by rewriting them? Absolutely. But there's a cool shortcut on this one. Can someone give me the answer without doing any work whatsoever? What does x equal? 15. It equals 15. And here's why. A log to itself cancels out, right? So I'm going to give you a slightly harder one, and I would like you to try this bad boy right here. I know, but here's what I want you to do before you freak out. Cancel out the 85s and the 85s, and then it's a super easy Algebra 1 problem, right? So a log to itself cancels itself out. Yeah. So these just cancel. So what are we going to have? 3x plus 5 equals negative 10. 3x equals negative 15. If you got x equals negative 5, you're on fire. Right? So you just watch for them. It's nice. It's nice when it happens. The second weird one looks even scarier, but I'm going to tell you, I'm not going to teach you how to do it. If you are dying for me to show you why this works, I can, but I'm going to go straight to telling you it's kind of like the other one. But if I show you how, like in A period, they were like, what? So I'm just going to go straight to the shortcut on this one. And here's the shortcut. If you take a number and raise it to the log of itself, it does the same thing. It cancels out, right? So just watch for those, right? And someone said, well, what if that had been a different number? Well, then we do it a different way, and we'll talk about that later. But at this point, whenever you have a number raised to the log of itself, they, just like the other ones, cancel out. It's not official that's Mrs. Tarantino telling you that's the shortcut, right? So, without doing any work whatsoever, can you try that bad boy right there without doing any work? You don't even have to write it down. It was got 12, yeah. Like people are like, yay. Okay, how about if we got a little crazy? Look at that. I want you to try this one. If you showed that problem to someone in another class, like in geometry, like, this is what we're doing, they'd be like, I hate you and I don't want to take that class next year. So think to yourself, is there a shortcut I can do on this? And there is, and then do the math for it. Do it real quick on your paper if you could. Did you say that? Someone said,
She said it first, then I heard it, and then I did
you
it
heard?
in my
Break my heart. Break my heart. Yeah. We got one other one. And then, okay, so if you did this, if you said, hey, that goes away, 2x minus 6 equals 14, and you went 2x equals 20, and you went x equals 10, like I'm sure Mosen did completely. Mosen did that completely, right? Yeah, sure you did. Then that's what you get. Last one. I need you to watch for this. That's right.
Yeah, light work.
Yay, right there. I need you to watch for this. This is going to come up a ton for the rest of this chapter. Anytime that guy, he's called the argument. And anytime the argument is one, guys, anytime that argument is one, the answer is always going to be the same no matter what this is. Because watch what I'm saying. 5 to what power will give me 1? How do I turn any number into 1? I use 0, right? X is 0. So on any of, Ava, I so need them to listen, right? So anytime you have any of these guys, it doesn't matter whether it's 50 or 5 or 51 or 151, it doesn't matter what's down here. If this guy is 1, it's gonna equal 0. That's how we can turn anything to 1. So you're gonna need to start watching for it. It shows up all the time. So tonight's problems are a little bit more rigorous. So my advice is, unless you see a cool shortcut, rewrite them and do them. So I'm going to give you some problems, and I'm going to cut, like, pick and choose, okay? So it looks like a lot. They go fast, and I need you to get good at them. So here we go. Don't ask me when I talk about, like, do we have to do all of these? I'll tell you what we need to do. And goodbye to my COVID friends. They probably don't have COVID anymore. I don't know what's wrong.